Welcome back to Click Academics. In today's video, I'm going to be teaching you guys how to solve this exponential equation. So we have 2 to the power of x plus 2 to the power of 3x equals 10. And what we're going to do first is we're going to rewrite this equation. We're going to write this as 2 to the power of x plus 2 to the power of x to the power of 3. Because remember, when we have something like this is equal to x times 3. We multiply the exponents, so we're simply reversing that. And this equals 10. And now what we're going to do is, since we have 2 to the power of x's, we're going to set 2 to the power of x equal y, the variable y. So y equals 2 to the power x. So now what we're going to do is we're going to replace all the terms that have 2 to the power of x to y. So this rewrites to 2 to the power of x. That's y plus y to the power of 3 equals 10. Now we're going to subtract 10 on both sides. So we get, let me rewrite this in order of exponents. We have y to the power of 3 plus y minus 10 equals 0. So now we're actually, to factor this, we're going to rewrite this y as, write it right here, y third minus 4y plus 5y. We're going to rewrite the y as minus 4y plus 5y, and we still have the minus 10 here, and this equals 0. Now, from y to the power of 3 minus 4y, we're going to factor out y. So we get y times y squared minus 4. And from 5y minus 10, we're simply going to factor out 5. So we have plus 5 times y minus 10 divided by 5 is 2. And all this still equals 0. And now what we're going to do is we're going to change our y squared minus 4 into y plus 2 times y minus 2. So we have y times y plus 2 times y minus 2. We simply just factored this y squared minus 4. And we're going to add this with 5 times y minus 2. And all of this still equals 0. And now, as you can see, since both terms have y minus 2 in them, we're going to factor out y minus 2 here. So if we factor out y minus 2, we get y times y plus 2 plus 5. And all of this still equals 0. Sorry. And now we've created two equations. We have y minus 2 equals 0 and y times y plus 2 plus 5 equals 0. Now let's solve our first one here. This one is really simple. We simply add 2 on both sides to isolate y, and we get y is equal to 0 plus 2 is 2, so y is equal to 0 plus 2. And our next solution, well, let's first start by distributing our y here to y plus 2. So we get y squared plus 2y plus 5 equals 0. And now, as you see, we have a quadratic equation here, and we want to factor this, right? So we're going to use our quadratic formula, negative b plus or minus the square root of b squared minus 4ac all over 2a. So b, remember, y squared is a, 2y is b, and 5 is c. So we have negative b, negative 2, plus or minus the square root of b squared, so 2 squared, 4, minus 4 times a, which is 1, times c, which is 5. And we're going to divide this by 2 times a. Remember, a is 1, so we have 2 times 1, which is simply 2. Now, let me bring this over here. So now we have negative 2 plus or minus the square root of 4 minus 4 times 1 times 5. That's 4 minus 20, which is negative 16. And as you see, we can't take the square root of a negative. That's not possible. Meaning this is wrong and this equation is wrong. So our only solution is y equals 2. And why don't we plug? So this is our only solution. So now, as you can see, y equals 2 to the power of x, right? So because we already know that y equals 2, we have 2 equals 2 to the power of x. And what to the power of, or 2 to the power of what equals 2? 1, because anything to the power of 1 equals itself, meaning x equals 1. Now, why don't we check our solution in this equation? So if we plug in 1 for x, we get 2 to the power of 1 plus 2 to the power of 3 times 1 equals 10. 2 to the power of 1 is 2, plus 2 to the power of 3 times 1 is the same thing as 2 to the power of 3, which is 8. This equals 10, and 2 plus 8 does indeed equal 10. So 10 equals 10. And this is right. So our solution here, x equals 1, is right. Hey guys, welcome back to Click Academics. In today's video, I'm going to be teaching you guys how to solve this exponential equation with, as you can see, 2 different bases. So what our first step is going to be is we're going to expand our right-hand side here. We have 5 to the power of x plus 2. And remember, let's say we have a to the power of b plus c. An important property of exponents is that we can change this into a to the power of b times a to the power of c. Because remember, when we're multiplying exponents, we add these two. So all we're doing is we're simply reversing this. So that's what we're going to do to 5 to the power of x plus 2. We're going to reverse it back to its original form and expand it. So 5 in this case is a, right? So we have 5 to the power of b. B is x times 5 again to the power of c, which is 2. And this is still equal to 2 to the power of x. Now, 5 squared, as we all know, is 25, right? So this is 5x times 25 equals 2 to the power of x. Now what we're going to do is we're going to divide both sides by 5 to the power of x. So if we divide both sides by 5 to the power of x, well, for this side, these two will cancel out. So on our right-hand side, we'll just have 25. And on our left-hand side, we'll have 2x over 5 to the power of x. And this can actually be written as 2 over 5 whole power x. And this is equal to 25. So now what we're going to do is we're going to take the log base 2/5 of both sides. So we're going to take the log base 2/5 of both sides. Well, these two actually cancel out because remember, the log is the inverse of an exponent. So because this is base 2/5, these two are going to cancel out. So on our left-hand side, we have x equals, and on our right-hand side, we have log base 2/5 25. And this is actually equal to, using the change of base formula, which is an important property of logarithms, log 25 over log 2/5. The change of base formula states that if we have a logarithm like this, log of this so this equals log of this over the log of the base. So now this can be converted to, let me write this over here, log 5 squared, because we're simply changing the 25 to a 5 squared, over log 2 minus log 5. Remember, when we're subtracting logarithms, we divide. So we're simply just inversing that. So log 2 minus log 5. And this, an important property of logarithms, the power property, states that we can just drop down the exponent here in front of the log. So this can equal 2 log 5 over log 2 minus log 5. And this is our answer in its simplest form. If we want a more simpler form, we need to use a calculator for that, but this is the most simplest form we can write our answer in.